Hi, welcome to the poleshiftnews, the home of the Maverick Observatory. Guys, since we're on the topic of cosmic particles and subatomic particles like muons, I thought the other day I would look into what research has been done on the discovery of these subatomic particles. Now, most of you have heard of CERN and the Large Hadron Collider, but most of you probably won't be aware that the total cost of the Large Hadron Collider was $52.86 billion. It's a number that none of us can comprehend. What was it that justified the expenditure of, not just one country's taxpayers' pocket going into this fund, but many countries putting into this fund to discover one thing: the boson-Higgs particle? How will we ever benefit from the boson-Higgs particle is beyond me. It really is. But the point is this: how did they justify to the public spending £52.86 billion on the Large Hadron Collider? And here is another facility, the huge Chinese Cosmic Ray Observatory, and they call it the Large High Altitude Air Shower Observatory. This one cost 1.2 billion yen, $180 million to build. It's at an altitude of around about 4,410 meters, as you can see, and they're in a static location, which means they're only going to observe from that location cosmic rays. So they're going to, so let's put it in perspective for you guys. They're going to detect, right, if I've got one detector here that detects muons, they're going to detect 4 more muons than what I do right here in this location. And where we're going to have the edge on them is that we're going to put these detectors in locations all around the world. And it's not going to cost £1.2 billion. It's going to cost a lot less than that. And we're going to get more bang for our dollar. But guys, the point is this: look at the amount of money that is being spent on this topic, cosmic rays, atomic particle detection. They're spending in total, globally, trillions of dollars on this topic. If you remember the other day I showed you this chart, it's about an aircraft that took off with a muon detector on board, and as you can see, from ground level to its maximum ceiling that the aircraft flew at for around about 6 hours, it was recording the amount of cosmic rays that it was detecting. And the point is this: they've not really got an edge on the amount of cosmic rays they're going to get through the altitude that they're at, because, like I said, if you're at ground level and you go only 5,000 kilometers above sea level, you're not going to get that many more cosmic particles. They would have probably been better off investing, instead of a ground-based facility, perhaps an aerial-based facility, purchasing an aircraft that could fly for a prolonged period of time and record the cosmic rays from the aircraft. They'd probably been better off at that. If they was thinking by building it at a higher altitude they was going to benefit from more cosmic rays, I think they'd have been better off going down the route of an aircraft, purchasing an aircraft. But we've got a good opportunity here, guys, to compete with facilities like that, because we are able to, unlike NASA, at the drop of a hat, just put one of our detectors in a given location anywhere around this world. When one of our subscribers, puts their hands up and says, yeah, we'll have one of these muon detectors, it could be in Brazil, Africa, Canada, United States. We can pop these all around the world and we can get global data on cosmic radiation and its levels, if they're increasing or not, and we can relay that back to you. And that's another important thing, guys. These companies that are doing this research are giving nothing back up. They're using taxpayers' money to build them. and they're giving nothing back up. We've had a few bumps in the road with our magnetometers, but I'm sure we're going to get them ironed out. And our muon detectors, our cosmic ray detectors, are going to go out around the world, and we're going to gather all this data, and it's going to come directly to you guys. That's the difference, between what the other organisations are doing and what we're doing here. And trust me, we are going to be at some point, and we know already at some extent, we are popping up on the radar because of the way we're doing it. If you just put it in perspective, yeah? If you're NASA and you want to set up an observatory in China, Hong Kong, India, Australia, you've got to liaise with the government. First of all, you've got to purchase a facility or build a facility, and then you've got to select the correct amount of staff to run that facility, train them, and as you saw with CERN, most of these people that work for CERN are on $120,000 a year per person. So the costs of doing it their way is extreme, guys, and that's how we're able to compete with them at this level with a little observatory like we've got. Is because we've got people that will take them on. There won't be no consulting with the governments or anything else. These people will take them on in their countries and report that data back to us, and we'll process it. How long we can get away with doing this is a question. I've been thinking about, because it's a bit cheeky, but it achieves results. A lot of countries would ask a lot of questions about NASA proposing such an idea of putting detectors in their country and then observing something from their location. They would obviously get a little bit concerned that there was a bit more going on than what they are actually disclosing. Probably a little bit of paranoia as well, and rightfully so. Why would a facility in another country like the United States want to put one of their detectors in your country? Is there more going on than what meets the eyes? And you can imagine all the red tape, but we bypass all that, guys, on YouTube. And as a result, we save millions of pounds. And not only that, we get the information back to you guys, because that's what is important. And that's something different that we're doing to all these other organisations. I don't know how long we're going to continue doing this before they do find a way of probably shutting us down, and I hope that's not the case, because it's very innocent what we're doing. We're just trying to discover what is happening to our planet with regards to the current situation that we're in, and that is twofold. First of all, the grand solar minimum, as you know, and second of all, the weakening magnetosphere. And even though we've only been recording the magnetosphere for the last 14 months and not noticed a massive difference, it's irrelevant. What's important is when the changes do happen, we will notice them, because we've got the equipment to do that. And of course, you, the average public out there, will get that information from our website and on our YouTube channel. So, guys, it's the weekend, and really the only thing to say is that we're working really hard at the moment here. As you can imagine, there's a lot going on. We're building the cloud generator. We are hopefully going to be in receipt of a couple of components that will allow us to run some tests. You're going to see the results of those tests early next week, hopefully. And we are just waiting for the PCB boards to be built and delivered to us, and that should be within the next week as well. And then it's just a case of building these boards up and putting these detectors around the world. We've got quite a lot going on, believe it or not, and the costs, even though we're operating on such a small budget, are escalating. Trust me, guys. £340 just for the PCB boards, and we've got lots of other components to build and lots of other components to order We were almost completed on the cloud generator. And what this means for you guys is that when the detectors are out there, you're going to get first-hand information with regards to how much cosmic radiation globally is inbound, not just from a static location like we just saw over in China. You're going to get it first-hand, how much is on the increase globally. And we know it's on the increase. We're at a grand solar minimum. We're in the trough of solar cycle 24. We know more cosmic radiation is inbound on our atmosphere more than ever at any point in the last 33 years. There's a lot going on in the last 33 years. Not to just mention, the fact that the magnetic North Pole has migrated 1,000 miles in the last 30 years. So, what we need is support, guys. It costs money to buy these components. It costs money to send these components out around the world, and it also costs time. And right now, we're not really covering the cost of one salary for one person at this observatory, and it is getting out of hand for me. I need some help. I could do with at least a couple more people on board here, doing all the other things as well that goes on here. But at the moment, I don't mind continuing like this so long as we get some support. That's the main thing. And if you want to help the observatory, then there's a couple of links down there. You can support us on PayPal, and you can support us on Patreon, and that really is it in a nutshell. We'll do the rest so long as we get the support. And it's not like we're being funded by governments here. It's crowd-funded, so remember that. We might get 2,000 people watch a video on YouTube, but probably 2 of those will be the ones that make a little bit of a pledge to support it. But I just want to say, I'm delighted with the amount of support that we've got. We've raised half the money already for the muon detectors to be built. I just hope it continues. And as a result of that, we will continue to give you the information which is critical right now. This is a big thing, guys. The last time the Earth went through a magnetic reversal was 780,000 years ago. And we are rapidly approaching a time where the sun seems to be going into a coma period. It's not producing much activity at all. And as a result of that, the heliosphere shrinks, more cosmic radiation inbound. Earth's having a problem with its magnetic poles right now. As a result, more cosmic inbound. And, all the biodiversity across all the ranges suffers as a consequence as that. And, all these organisations have got plenty of money rolling in, and they're not giving no information out. Can you believe that? So, this is your observatory, and you get the information back to you, and all we require to do that is some funding to keep it going. So it's as simple as that. Links are down there, guys, and as always, have a great weekend. I'll say what I usually do. Bye for now.